Hello and welcome to Algebra 1, Chapter 3.1. This is the beginning of our discussion on Chapter 3, which is called Functions and Patterns. In 3.1, we will be discussing representing relations. So let's figure out what that is. A relation is a set of ordered pairs. And so notice we have the word set, and remember sets come in squiggly brackets. And it's a set of ordered pairs. So we might have, let me erase this last one here. Maybe we have the ordered pair 1, 2, and negative 2, 3, and 0, negative 3. That is a set of ordered pairs. You can represent a relation in several different ways. First of all, by a set of ordered pairs, just like we just did. Or you can represent them using a table. So notice this group of 3 ordered pairs we used for our set up here. They are all in the table. Those 3 are on the graph. And then we also have what's called a mapping. And a mapping is just, it's a group of x's and then a group of y's, and we're going to draw a line across, an arrow across, to match up the ordered pairs. Okay? So mapping shows how each element of the domain, remember the domain is your x's, is paired with an element from the range. Remember the range is your y's. So if we have a relation, and I know it's a relation because it's a set of ordered pairs, and I want to express it as a table, a graph, and a mapping. So as a table, it's going to be an XY table, and just start at the top, 4, 3, negative 2, negative 1, so I'm getting these just from my ordered pairs here, negative 3, 2, 2, negative 4, and 0, negative 4. There is my table. Okay. As a graph, so as a graph, let's draw in our axes, put a few tick marks in here. Okay, and to graph them, to graph 4, 3, starting at the origin, go right 4 and up 3. About there. Negative 2, negative 1, go left 2, down 1. Negative 3, positive 2, go left 3, up 2. 2, negative 4, go right 2, down 4. And 0, negative 4, go straight down 4. So there's our 5 ordered pairs graphed. All right, and then our mapping. We're going to have an x and a y, and most of the time I see these, these are in numerical order. So let's look at maybe a negative 3, negative 2, 0, 2, and 4. And then negative 4, negative 1, 2, and 3. Notice I did not put negative 4 in my mapping twice. So negative 3 is going to map to 2. Negative 2 is going to map to negative 1. 0 is going to map to negative 4. 2 is going to map to negative 4. And 4 is going to map to 3. Okay, so the last thing we want to talk about is domain and range. Remember your domain is your x's, and let's label, we're finding the domain, and it's a set of x's. And we should put them in numerical order as well. And if you refer back to your mapping, if you put them in numerical order for your mapping, they're already in numerical order for your domain and range. So then range is my set of y's, so I'm going to go and get my y's. Remember, they should be in numerical order and there are no repeaters. So we know domain is x and range is y, but which variables do those represent, or which values do those represent? Domain represents your independent values. See here if I can spell. And those are your x's. Range represents then your dependent values, and those are your y's, because we say y depends on x. So this is helpful when deciding which should be the domain and range in real life problems, which one depends on the other one. All right, so we have a table that shows the percent of students satisfied with their grade at the time of the survey. Determine the domain and range of the relation. So the domain is the x's, range is the y's. So which one is x, which one is y? Well, one way you could look at it is it always gives you x first and then y. I shouldn't say always. Most of the time it does. So there's one way to look at it. Always x is first, then y. But if I'm looking at year and percent satisfied, does the year it is depend on how many that were satisfied, or does how many that were satisfied depend on the year? Right, how many were satisfied depends on which year it was. So this is your y, this is your x. So my domain is my x's, so we're looking at 1996, 1999, 2002, and 2005. And my range is my y's, and so we're looking at 21, 32, I'm going to put 51, and then 60, so that they're in numerical order. Graph the data, okay? Everything here would be in the first quadrant, so I'm going to treat this just as the first quadrant. So I'm going to draw my axes here on the ends. And we're always going to label, so there's year, percent satisfied, okay, year, tell you what, we're going to do the little break and start at 1996, that'd be 97, 98, 99, I'm just going to label 2000, 2001, 2002, 2003, 2004, 2005, okay. Percent satisfied, we might again do a break and maybe start with 20 and do 25, 30, 35, 40, 45, 50, 55, 60. You want to make sure to always spread your graphs out as much as possible. Don't make them really condensed. Okay, so we got to plot some points. So in 1996, 21 would be about there-ish. 1999, go up to 32. Oop, I think I was over too far. 32 would be there. 2002, go up to 60. And 2005 at 51. There we go. That's what it looks like. We're not going to connect them. We're just going to plot our points. What conclusion might you make from the graph? Well, there's lots of conclusions you could make. It does look, though, that over time, the percent of people satisfied with their grades has increased. Even though, yes, it did fall a little, it is still considerably higher than when it started. So that might be a good conclusion you could draw, or see if you can come up with something on your own. Last thing we're going to mention here today, and then we'll finish it up in class, is what an inverse relation is. And to get an inverse relation, all you do is switch the coordinates in an ordered pair. So if an ordered pair is 1, 2, the inverse would be 2, 1. So the domain, that's your x's, of the relation become the range in the inverse, they become the y, and the range in the relation becomes the domain in the y, because the x becomes a y and the y becomes an x. So if you just understand that part, we'll continue from there next time. Let me know if you have any questions, and have a great day.